Okay, welcome back. I know you've missed this. So recall that the formal definition of a derivative is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. This is, of course, very tedious. It's the long way of finding a derivative. There is a more efficient way of going about finding derivatives. So, welcome to the power rule for derivatives. This is simply a shortcut. And to use this shortcut, we need to make sure that every term is expressed in the following form, and that is x to some power. So let's take a look at some symbols for the derivative. Usually we will see f prime of x. Sometimes we see just y prime. Other times you'll see dy dx. It's not read dy divided by dx, it's read dy dx. And sometimes you see d dx, like that. Okay, all those symbols mean to find the derivative. So if we have a function y equals c times x to some power n, then the power rule says we can multiply that power down in front to whatever that coefficient number is, let's call that c, times x, and then raised up to the n minus 1 power. So let's look at some examples. Let's see how quick and easy this is. I'm sure you'll likely recall it from last year as well. So 5x to the fourth, we have that term expressed as x to some power. So you simply multiply down. 4 times 5 is 20, and then subtract 1 to your power. So you have 20x cubed for the first term. From there, we would have minus 9x squared plus 2. Now, right here, the 2x term, the reason it's 2 is because the power is 1. Multiply that down, and then subtract 1. You really have an x to the 0 here, but x to the 0 is just 1, so we don't bother to write that. So we would just have 20x to the third minus 9x squared plus 2. And recall that the derivative of a constant is just going to be 0. If you were to think about the line y equals -7, it's a perfectly horizontal line. The slope is always equal to 0. So the derivative everywhere on this line is 0. So that's why the derivative of a constant is just 0. So this would be our expression here for our derivative. Next one gets a little more complicated. Now we're dealing with some negative powers and some fractional powers, but it's still the same idea. You multiply down, so that's -40 x to the, now careful, we're subtracting 1, so that'll put us further into negative territory, so -6. Next term, multiply down, that'd be plus 8x to the -3. Same thing with fractions, multiply down, 2/3 times 6, that gives us 4x, and then you have your 2/3. You're subtracting 1, which is the same as 3/3, so if you have to do it this way, okay, go right ahead. So -1/3 would be our new power there. Okay. Next one, I'm going to use f prime of x, since I'm given f of x as my function. Now before I do my derivative, I'm going to put an equal sign right here, because I need to rewrite this in a different form. You need to keep in mind your exponent rules. 4 divided by x. If I were to bring up that x, it's going to become x to the -1. Right now on the bottom it's a +1. Bringing it up to the top is 4x to the -1. The reason we need to do that is because, again, to use the power rule, x has to be expressed to a power. Plus, now x cubed over 5, that's the same as just writing this as 1/5 x cubed. Notice that I wrote equals right here because it's still equal to f of x. Down here, notice I put f prime of x. Okay, so now I'm going to do my derivative. So we multiply down, we subtract 1. Same thing here. We multiply down, we're going to have 3/5, and then x squared for our final answer. Okay. Let's move on. A few more. So again, we have some more prep work to do here. 5 over x squared, that's the same as 5x to the negative 2. Plus, now this 6 over 3, I can turn that into just 2. And the x to the negative 4 in the bottom, I can bring that up as x to the positive 4. Now I need my derivative notation. So we're going to multiply down. So minus 10x to the negative 3 plus 8x cubed. You'll get really quick at this the more you do it. Just make sure that you remember that here it's equal. We just wrote it in a different form. Down here we need to write a new stem f prime of x. Number 5, we have some radicals. Square root of x, recall, is x to the 1/2 power. Next term, recall that a cube root is really a 1/3 power. So x to the 5th to the 1/3 power turns this into x to the 5/3. So now my derivative, I would have 1/2 x to the negative 1/2 when I subtract 1 plus 5 over 3 x raised up to the, and again we have 5 over 3 minus 1, which is really minus 3 over 3. That's going to give me 2 over 3 for my new power. Okay. Now, number 6, we can't just go term by term and apply the power rule. We have a quotient here. So what we're going to have to do, since we're dividing by one term, we need to divide each of these by that x squared. So the first term, x squared divided by x squared, that's just 1. 6x over x squared, well, that becomes 6 over x, which is 6x to the negative 1. And then we have minus 2 over x squared, which becomes minus 2x to the negative 2. Again, that's still equal to y. That's not my derivative. My derivative, y prime, well, derivative of 1 is 0. Then I'd have negative 6x to the negative 2. And then plus 4x to the negative 3. Okay. And the last one here. Later on we will review the product rule. You may recall it from last year. But if not, with something like this, recall that we want to do FOIL to multiply this pair of binomials together. So if we do our FOIL, we're going to have 12x squared plus, on the inside I'm going to have 4x, on the outside I'm going to have a 15x plus a 5. So 12x squared plus 19x plus 5, that's still equal to y. Okay, I have not found my derivative yet. Now that I have done some algebra and I have written it in a different form, okay, we can now easily find our derivative using the power rule. So 24x plus 19 would be our final answer.